Okay, everyone, we're going to get started. All right. Welcome to the event. If we lose the Arctic, we lose the world. I'd like to thank the team at the Cryosphere Pavilion and the International Cryosphere Climate Initiative for hosting this event. My name is Gabrielle Gundry, and I'm a student of Arctic Security and Disaster Management at the University of Alaska Fairbanks. I'm presently working with the National Environmental Policy Act in the United States, and I've also worked with AMAP, the Arctic Monitoring and Assessment Program, in conjunction with NOAA, the United States National Oceanic and Atmospheric Agency. And with that, I'll dive right in. The Arctic is the front line of climate change. The region is currently warming 3 to 4 times faster than the rest of the world, and changes in the Arctic are affecting the lives and livelihoods of billions of people, both in the Arctic and beyond. Melting Arctic land ice is the largest contributor to rising sea level globally. The impacts of climate change, some of which are associated with rapidly disappearing Arctic sea ice, are affecting weather systems across America, Europe, and Asia, generating frequent and more powerful extreme events than ever observed before. The sources and pathways of pollution in the Arctic are changing because of the loss of the Arctic cryosphere. Increasing acidification of the Arctic Ocean is threatening the polar marine systems and fisheries, one of the economic pillars of the surface permafrost usually disappears and from nearly all mountains and will cause extensive infrastructure damage. Moreover, today at 1.1 degrees Celsius of warming above pre-industrial levels, and emissions are about the same as Japan's. Traditional ways of life and cultures of local and indigenous peoples, as well as species and ecosystems, may disappear indefinitely. The world does not take effective measures to reduce the greenhouse gas emissions that are driving temperatures. Though the effects of climate change are being felt in the Arctic, the long-term impacts will be felt far beyond the region. Now I'd like to transition the event to the outline. First, there will be key presentations, followed by a panel discussion. Please save all the questions for the panel discussion. To our speakers, please be mindful of the time, so as the optimal length of their presentations, and to allow enough time for the panel discussions. I would first like to introduce our speaker, Professor Maxine Burkett. Professor Burkett serves as the Deputy Assistant Secretary for Oceans, Fisheries, and Polar Affairs in the Department of State's Bureau of Oceans and International and Environmental and Scientific Affairs, where she oversees the formulation and implementation of U.S. policy on a broad range of international issues concerning the oceans, the Arctic, the Antarctic, and marine conservation. Maxine, thank you for being here with us today, and the floor is yours.
Thank you so much. It's really wonderful to be here. And to open this, what I think will be a very informative discussion with multiple perspectives, offering insight onto what is happening in the Arctic region at this point. It's really a privilege and an honor to be working in this space and on this region at this moment in time. As mentioned, the Arctic is warming 3 to 4 times the rate of the planet, and the effects of this dramatic warming have resulted in a marked decrease in sea ice extent over several decades, an increase in Arctic wildfires, and increasing permafrost thaw, all of which I know our presenters will dive into. As well, the effects of climate change are also affecting the people who live in the Arctic, especially indigenous peoples who live in remote Arctic communities. All of this is of significant concern to the United States. And we recently released an updated national strategy for the Arctic region, which summarizes our main line of effort to address these issues. One of the 4 pillars of the strategy is to build resilience to the impacts of climate change, while also emissions from the Arctic as part of sort of our broader global mitigation efforts. We also want to improve scientific understanding of how climate change is affecting the Arctic and to conserve Arctic ecosystems. And to do this, we will partner closely with indigenous communities in the Arctic, both at home and abroad, as well as the public, private, academic, and non-governmental sectors. And all of this would be to harness the full range of knowledge and resources required to meet these goals. Another important pillar of the strategy it really is key to our understanding of the Arctic Council and its role in promoting international cooperation and governance. And so we will work to sustain the institutions institutions for Arctic cooperation in the Arctic Council and position these institutions to manage the impacts of the increasing activity, especially in the region. And so if I could just spend a couple minutes sort of diving into a bit more the importance of the Arctic Council, which I think cannot be overstated, especially at this time of security. Some of the examples of the work that we are doing as the United States as part of the Council include key areas in response to permafrost thaw and in response to wildland fires and protecting our environment. But with respect to the permafrost thaw, our lines of effort include how to increase monitoring of permafrost thaw so it can better be incorporated into climate models, incorporating those models into global mitigation strategies, and co-developing with Arctic indigenous communities a robust adaptation framework. With respect to Arctic wildland fires, projects that we're hoping to address is the extent to which wildland fires increased in the Arctic and how these fires affect those ecosystems, how Arctic states can cooperate in order to be able to respond more effectively to these fires, and what are the effects from the increase in smoke and black carbon from these fires, including effects to humans, as well as the positive feedback loops that we see in terms of climate impacts. With respect to the Arctic marine environment, this is also of significant concern. Protection is key as the Arctic Sea declines. The ocean is more conducive to shipping traffic, which has increased markedly over the past several decades. And the U.S. plays an active role in the Arctic Council's protection of the Arctic Marine Environment Working Group, which conducts a wide range of activities related to the protection and sustainable use of the Arctic marine environment, especially as we see this increased shipping traffic threaten potentially significant negative impacts. And then last but not least, the support for remote Arctic communities. We are deeply committed to meaningful coordination and engagement with Arctic indigenous peoples to address some of the pressing climate remote Arctic communities. We support ongoing work in developing renewable energy options for these communities, as well as a strong focus addressing the physical and mental health in the community. Oh, it is not. Can you hear me better now? Okay, I'm closing. So I hope you heard most of what I was saying. But in conclusion, I emphasize that the United States is committed to addressing the impacts of climate change in the Arctic region. We'll work with our allies and partners to sustain existing institutions for Arctic cooperation, and we'll continue to build resilience to the impacts of climate change in partnership with the communities in the Arctic region. We really appreciate the invitation to speak, and I'm looking forward to hearing more from the panel. So thank you again for the invitation, and looking forward.
Thank you, Maxine. I really enjoyed your thoughts on Arctic cooperation. Our second speaker today is Professor Jason Box from the Geological Survey of Denmark and Greenland. Jason is a polar climatologist and glaciologist working on Greenland ice sheet changes, reflecting on global climate issues. Jason is a contributing author to the Intergovernmental Panel on Climate Change, or IPCC, 4th and 5th assessment reports, and chapter lead on several AMAP reports. Thank you, Jason.
Thanks. I'll briefly talk about the work of Arctic Monitoring and Assessment Program to assemble records, observational records, measurements of what's happening with the climate in the Arctic. It's good to turn on the clicker. So as you've heard already, and as you can see here, Arctic climate is warming actually at an increasing pace. Used to be 2 times as fast as the world, now 3 times, by some metrics 4 times as fast as the global temperature increase. Zooming out to 1900, temperature records, what I want to really point out here is the jump in Arctic temperatures that occurred after 2005, and this has been attributed to increase in the frequency of so-called winter warm events. Most of the Arctic warming is in winter, and that jump in 2005 with declining Arctic sea ice. So most of the warming signal is over the Arctic Ocean, the loss of Arctic sea ice, and the many feedbacks that are associated with that, more heat release into the atmosphere in winter, more moisture-laden storms in winter is part of that now 4 times global warming trend. Greenland is warming not so fast, only twice as fast as the globe. So this is some good news for the melting of Greenland, you might say. And you can see that in this map of the temperature change, with most warming in the sea ice retreat areas of the Bering Sea. And around Greenland, it's less warming. A number of there's a sustaining feedback from Greenland. It can actually be brighter at the upper elevations in warmer years, for example. So on to precipitation. This is the change in snowfall. And where the atmosphere is cold enough for snowfall to happen, there is more snowfall. You can see the green colors are increasing snowfall over much of the Arctic Ocean, southeast Greenland, parts of Norway. And the brown colors, less snowfall across the North Atlantic. And it's actually there's increasing rainfall because of warming. The temperature threshold is being crossed into melting more often. So that decrease in snowfall is really at the expense of increasing rainfall. For an overall pattern of a wetter Arctic, more snow on Greenland, that's shown in observational records as well. So with precipitation increasing in the Arctic, we also see Arctic river discharge increasing. The Eurasian sector is, as you can see in the blue bars, it's the largest source of freshwater discharge into the Arctic Ocean. The disruption of the increasing freshwater discharge is strong because the Arctic Ocean basin contains only 1% of global ocean volume, but the discharge is percent of global river discharge. So there's a huge freshening perturbation that's happening with this kind of 15% increase in Arctic river discharge in the last 4 years. We assembled a record of permafrost temperatures from around the Arctic, and what we find is that the coldest permafrost temperature increase is the largest. So the coldest permafrost is warming faster. The warmer permafrost is even crossing in a kind of a permanent thaw in the warmest records. The trend is less in the warmer records because of the role of meltwater heating from refreeze at depth. Along with permafrost degradation that comes with warming is increasing coastline erosion. So there's an acceleration in coastline erosion around the Arctic. Part of the acceleration is from reduced sea ice, which increases wave action on coastlines. Increasing precipitation, permafrost thaw is increasing landscape disruption. These are thaw slumps, thermokarst lakes, the transformation of Arctic tundra into a wetter environment, more sunlight absorption by the lakes, more activation of permafrost carbon, methane release. And just a point about abrupt thaw process. Even though, as you saw, temperature increase can be gradual, there can be and are abrupt processes where water, once it's there and ponding, it can infiltrate to depth and produce permafrost heating at depth in a matter of a season or a few years. So besides the creeping up of trends, there are abrupt thaw processes that make us concerned about the carbon stored in Arctic permafrost. I think this is my final slide, and on fire, observations document a signal of increasing fire, which is linked with warming. A warmer surface dries more despite more precipitation, because evaporation goes up nonlinear with temperature. So you have a drying of the landscape, drying of forest. Then more evaporation from the surface promotes cloud development and lightning ignition of fire. So there's actually a link between warming and increased trigger from lightning because of convective cloud development. The amount of carbon coming out from fire is equivalent with a medium-sized country. We're talking tens of megatons of carbon from fire. But of course, it will compound the warming problem and add to elevated carbon in the atmosphere, representing an amplifying feedback. And I think I'll end on this slide, which is in each 15-year trend, this is land ice, glaciers, ice caps, Greenland. In each 15-year trend, you can see we found increasing rate of sea level contribution. So Arctic land ice contribution to sea level is accelerating. The global sea level rise curves are now only recently recognized to be fully accelerating. And in the case of Greenland, that acceleration is probably just beginning. As climate continues warming, as we expect, the rates should increase. Antarctica is also included here for comparison with Greenland and Arctic glaciers contributing more currently to sea level rise. And there's some chance, perhaps a likelihood, that Antarctica will one day take over for the leading geographic source of sea level rise. But the Arctic is the largest source of sea level rise. The work assembles these multi-indicators. I've talked about a lot of them here. Again, this is published and work updated by the Arctic Monitoring Assessment Program, AMAP. Thanks for your attention.
Thank you, Jason. That was a great general overview of Arctic change, and also a great insight into the quick pace that it's happening at. So our third speaker joining us remotely is Professor John Walsh from the International Arctic Research Center, University of Alaska, Fairbanks. John has contributed to several AMAP reports as well, and has recently won the Mohn Prize for his continuous leading role in generating our common understanding of how sea ice dynamics link intimately with ongoing changes, including extreme regional events throughout Arctic. John, thanks for participating today.
Thanks, organizers, for giving me the chance to speak. I believe Heidi will be running the slides. Heidi, do we have the slides showing? Very good. Climate change has its greatest impacts through extreme events, and the Arctic is experiencing more than its share of extreme events. The next slide shows there are many types of extreme events. We can distinguish extreme events in the driving variables, temperature, precipitation, and so on. And we can identify extreme events and their consequences, the bottom half of the slide. In the interest of time, I'm going to focus on two types of extreme events, the ones in red, storms and wildfires. Next slide. Next slide shows the impacts of storms. These are scenes of coastal flooding in small villages of Alaska during several recent storms. You can see how these communities are literally underwater, and there are large amounts of erosion associated with these storms. So these are high impact events, not just in Alaska, but along Arctic coastlines around the Northern Hemisphere. Next slide shows a particular event that I'd like to highlight. This is an event that illustrates the connection between the Arctic and the rest of the world. It was a storm in late September of this year, an ex-typhoon named Merbok. It moved into the Bering Sea and impacted Western Alaska. Next slide. The connection to the rest of the world has to do with the storm's trajectory. As a typhoon, this storm originated in lower latitudes, but it moved over exceptionally warm water. The track in this diagram is shown by the dots, and those red areas represent areas of the North Pacific that were at record high temperatures, record high sea surface temperatures. Those high temperatures were part of the background climate change, but they fed this storm, reinforced it as it moved into the Bering Sea region, and led to some record low pressures. Next slide shows the impact of the storm on sea level along Western Alaska's coast. There was a 4-meter rise in sea level associated with the storm. It's actually a larger sea level rise than occurred with some of the more publicized hurricane events that occurred this past year in the lower 48 U.S., part of the United States. Next slide. The big concern now is that these high wind events are projected to increase. This graphic shows the high wind events in the deeper blue as they're expected to change through time through the 21st century. You can see that by the end of the 21st century, there's roughly a 25% increase in the frequency of high wind events. This is for the northern Alaskan coast. And there's a double-edged sword here. The next slide shows the impact, shows the record of sea ice coverage along the coastal regions, northern Alaska. These are the regions that are vulnerable to the storms. This diagram depicts the open water period from 1850 through 2021, starting at the bottom, 1850, and going through the most recent year at the top. The left-right scale is January through December. You can see how in the previous century, there might have been 1 or 2 months of open water. In the past decade, 4 to 6 months of open water. That means the period in which these storms can impact the coast with the flooding and erosion is 4 or 5 times what it was back in the 20th century. Next slide. Next slide shows the projected changes in the sea ice through the 21st century. The main point here is that only under the extreme mitigation scenario, the IPCC's SSP1 scenario, will sea ice stabilize. Under all other scenarios, summer sea ice disappears. Next slide gets us into the wildfire, second type of extreme event I wanted to cover. This is a photo of wildfires on the Alaska tundra this past summer. Next slide shows the historical record of days with visibility reduced by smoke in interior Alaska, Fairbanks, where our institute is based. Smoke reduction is associated with health impacts. It's associated with a damper on the tourist season. You can see here how the frequency of smoke days has increased dramatically over the last couple of decades. Jason alluded to this in his talk. The next slide shows the record of the flammability index. This is the June flammability index computed for the northern land areas. You can see how in much of the boreal forest, the landscape has become more flammable in early summer over the recent decades. That's especially true for large areas of Siberia. Or the next slide shows the record of wildfire burn areas over to 60 degrees. This is from a paper that just came out in the last couple of weeks by Descalz and collaborators. It shows the Siberian wildfire burn area, the top panel from different sources. The more ominous panel is the bottom one. That shows the burned area in peat, carbon-rich peat areas of northern Siberia. So this is the diagram that deals with the release of greenhouse gases that Jason referred to a few minutes ago. And the last graphic, the next slide, shows the projected changes. This is in the next slide. Shows the projected changes in the carbon emissions from Siberian wildfires as a function of the greenhouse gas emission scenario. Low emission scenario is in blue, high emission scenario is in red. There's a striking difference between the two. The final slide is a summary then, brings these topics together. Final slide is a statement that wildfires and storm conditions are both increasing in the Arctic. They have global connections. Storms are driven by global warming. The wildfire carbon release has global impacts. So the linkage does work both ways. The main message here is that the trajectory of both types of extreme events is highly dependent on the greenhouse gas emission scenario. Really only under the emission scenario that meets the Paris Agreement target do we have any hope of stabilizing the sea ice and the storm impacts as well as the wildfire impacts. So with that, I'll stop and thank you for your attention.
Thanks so much, John. And also joining us remotely is James Overland from NOAA, the National Oceanic and Atmospheric Administration, more specifically at the Pacific Marine Environmental Laboratory. James works as a scientific support for decision makers on climate change and ecosystems in the Arctic and subarctic. All right, your first slide is up and you can begin talking.
Well, good afternoon. Can we go back one slide?
Yes, go ahead.
Okay. I'm going to speak to increase in catastrophic impacts on the ecosystem and communities in the northern Bering Sea. Bering Sea lies between Alaska and Siberia near Bering Strait, and the Bering Sea has the largest commercial fishery in the U.S. and there are many coastal indigenous communities. Next slide. On the left here is how far the sea ice extent, how far south it reaches historically, and pointing out 2018 and 19 were record minimum sea ice, and so we have a positive feedback between loss of sea ice, warmer temperatures, and southerly winds and storms that John was bringing up. Of interest on the right side is a location map for Alaska and Siberia, and this shows the sea ice thickness this last winter. And interesting case was the southern extent of sea ice in green was not that different from historical conditions, but the brown shows that the sea ice thickness was only about a third of what it's been recently. So this feedback between warmer temperatures, sea ice, and southerly winds are completely changing the northern Bering Sea. So that's the physical driver. Next slide. So this has a major impact on the ecosystem in the northern Bering Sea. The southern Bering Sea, lack of ice is more interannual variability, but the northern Bering Sea was an Arctic ecosystem rather than a subarctic ecosystem. And fish from the southern Bering Sea moved north with the warmer temperatures. Pacific cod and pollock primarily. And in 2019, the minimum sea ice year, there were almost 1 million fish had moved to the northern Bering Sea compared to previous years in 2010. And while there's a little less now in the last couple of years, there's still over 500,000 fish still remaining in the northern Bering Sea. In contrast, Arctic cod, which was a major fish species in the northern Bering Sea, has basically disappeared because of less ice and more warmer temperatures. And the pollock and Pacific cod are adult fish. They're a major predator on the rest of the ecosystem. So they're chowing down or eating all the small forage fish and larval fish that were the basis of the Arctic marine ecosystem. And so their predation have decimated all the smaller fish that were the basis of the previous ecosystem. So the main part here is the predators moving north and decimating the whole ecosystem. Next slide. So this has major impacts. Snow crab are gone, and northern salmon runs are gone. This has decimated the commercial fisheries there. Birds and seals that depend upon the small forage fish are having problems, and all this is affecting food security and economic and cultural activities of the indigenous coastal villages. Next slide. So we think that these conditions of low sea ice and warm temperature, the frequency of them are going to continue into the next decade. So we're talking about current and near future impacts rather than 2040 or 2050. Historically, on the left is a weather map of temperatures during the winter, and there's a strong difference between Arctic temperatures and the southern Bering Sea and Alaska, shown by the strong color gradient across the Bering Strait. The difference in temperature creates a difference in pressure. In the upper right is the historical north-south pressure difference. And this pressure difference keeps the cold air bottled up in the Arctic historically and diverted storms away from the northern Bering Sea and the Arctic. However, in the last 5 years, because the Arctic is warming faster than farther south, it's eroded these strong temperature and pressure differences, which was the Arctic front. So if the storm curves northward, as Sean showed, there's nothing to stop those storms all the way moving into the northern Bering Sea and Alaska and the Chukchi Sea. So we consider that the frequency of these events will continue. Next slide. So in summary, we consider there's going to be catastrophic changes of the Arctic ecosystem near Bering Strait and major impacts on the human and society in terms of economics and cultural impacts. And because of the weakening of the Arctic front, we consider that these changes are ongoing now and will continue to increase over the next decade. Thank you.
Thank you so much. I'd like to invite our last speaker to the stage, Susanna Israelsson from the Sámi, from the northern part of Swedish Sápmi, the homeland of the Sami. She was born and raised in a reindeer herding family and holds a degree in political science from the Luleå University as advisor in the Sámi Council's Arctic and Environmental Unit, mainly covering the local communities and indigenous peoples platform and UNFCCC. Thanks.
Thank you so much, and thank you for having me. So my name is Susanna Israelsson, working for the Sámi Council, which is an indigenous peoples organization that represents Sámi civil society in Norway, Sweden, Finland, and the Russian Federation. And I wanted to start with this quote that is actually from my father. And I really hope you can see the text. And if you don't, you're very welcome to come closer, because I will have a few more of those. I come from the people of 8 seasons, grown up with the reindeer husbandry at center, which is a core part of Sámi culture. As we all know, climatic disasters are increasing in frequency and severity in the Arctic, and thus in Arctic indigenous traditional and sacred territories, resulting in displacements, cultural and economic losses, and emotional stresses. This threatens and affects cultures, livelihoods, health, and overall well-being, and these impacts are societal. Indigenous peoples globally are already experiencing irreparable damage to their languages, knowledge systems, and livelihoods due to loss of biodiversity and ecosystems, losses that are economic and non-economic. And in fact, according to IPCC in their latest assessment of non-economic losses and damages, including loss of societal beliefs and values, cultural heritage and identity, assessments are lacking. and aggregate losses and damages would be higher if such values were considered. We talk about the 1.5 limit in these climate negotiations, but we have already passed that in the Arctic, and we're facing a region that we don't recognize. I can change slides for you. The seasons are changing in Sápmi, the homeland of the Sami, and therefore causing severe challenges to Sami culture and livelihoods. A classic example from my culture is our many words for describing snow conditions. We have over 300 words for this only. Everything I personally know about how to read and describe my environment, weather conditions, and their specific impacts on reindeer husbandry and other seasonal activities is connected to the reindeer husbandry. But as snow conditions are changing in Sápmi, so is our language too. We have rain on snow, thawing, freezing events, which is causing our reindeer to starve in their natural environment because they can't dig through the snowpack for food. And we have found elk too. Species are migrating north and now compete with indigenous Arctic species. Key species relevant for food security are declining throughout Sápmi. Arctic char in inland lakes and rivers have been replaced by trout, among others. Pink salmon is increasing throughout rivers. As just a few examples in a wider system of species and ecosystems, the current and projected future changes coming from climate change risk leading to major impacts on the resource foundation for the Sami culture as we know today, meaning that our culture and traditions, as well as our food security, is at severe risk of disappearing. And as a double burden, now we lose our lands for the sake of mitigation and developments covered under labels such as green and sustainable. We have to prepare for the change that is coming from a changing climate, but at the same time, also from the impacts in change in land use and the loss of lands that we did not consent to. Deforestation, excessive exploitation of mineral resources, and industrial developments altogether are direct threats to all culture's existence in Sápmi. We can't talk about mitigating or adapting to climate change in a Sámi text without talking about other developments going on at the same time, as if everything happens in silos. A study published recently highlights that there is only 4% of reindeer grazing areas that are now untouched from activities such as forestry, mining, tourism, roads, and railways in the 3 Nordic countries. 4%. This is a picture of my father. Sorry, it's been a long 2 weeks. This is a picture of my father. I've grown up next to what I think is the Northern Europe's biggest copper mine. And this is us looking for reindeer that accidentally have, accidentally wandered into the industrial area. And this is not the future we want. As one wise reindeer herder active at Finnmark area in the north of Norway said, our geographical area for adaptation is shrinking, which means we also lose the possibility to adapt. Potential threats against our traditional lands and way of life are altogether threats to identity, values, and cultural practices, and therefore also the possibilities to pass these on to future generations. Everyone looks to the Arctic for increased production. And paradoxically, it is indigenous peoples that have to reduce ours. And yes, our historic presence is a manifestation of our resilience in the Arctic. We have adapted historically to changing conditions. Sami livelihoods, ways of life, we have good competence with dealing with changes. We deal with them all the time. Weather, wind, surroundings, we deal with them all the time. But what I want to say here is that I see a dangerous trend out there, a dangerous perception, and a constant belief that indigenous peoples' cultures and livelihoods should adapt and can adapt to any new reality. What I do know is that we are dependent on healthy ecosystems as they are the foundation for all culture, traditional livelihoods, food security, intergenerational transmission of Sami knowledge, and our Sami languages. In fact, in Sami cosmology, humans are seen as part of nature, where maintaining harmony within ecosystems is the core value. Our guiding principles are modesty, taking only what is needed, and respect. It also brings the responsibility to maintain a balance within the ecosystem and to safeguard a healthy environment as a foundation for all life. We are taught that we borrow the land from our grandchildren. So let me share this quote from a reindeer herder in Sápmi. Climate change, changing landscapes, and loss of lands result in impacts on the health and culture of my people. These point at negative health impacts that include stress and depression due to uncertainty regarding, for example, the status and future of reindeer husbandry as a livelihood. Climate change, then trying to adapt to constantly shrinking lands with increased costs and financial pressure related to, for example, adaptation measures, adds a heavy burden on our communities. This has shown to reduce psychosocial health and increase suicidal thoughts among herders. It has societal impacts, and the risk that we are facing in the future, I cannot even put in words. So, example, the previous winter was especially harsh in Sápmi, and in Finnmark, Norway, herders reported working all hours of the day to keep herds alive. Some with expenses doubled compared to previous years due to increased prices and, of course, due to the need of supplementary feed. The heavy workload and psychosocial stress is not only affecting herders but also their families, which made the Geological municipality doctor alarm the Sami parliament about the situation, since families increasingly found themselves in physical, psychosocial, and financial stress. Did you all see that? Or is this the previous picture? Okay. Anyway, so climate change and extreme weather conditions are one part in a larger puzzle. Increased competition over lands, increased number of predators, as well as increased costs and financial pressure related to the livelihood are factors that add to the burden. And now I'm only talking about the reindeer husbandry. So yes, other challenges are arising, stemming from climate change and response measures to mitigate climate change. Land grabbing is increasing local conflicts and colonial power imbalances, creating polarization and racism on the ground. This puts even more pressure on our communities. We talk about intergenerational equity and climate justice in these climate negotiations. Our knowledge and how we understand and interact with the nature is intergenerational equity embodied. As one share of responsibility to protect our land for future generations. So if states are serious with mitigating dangers and also making sure that we all can adapt to it in a changing Arctic, indigenous peoples need to be equitable partners in these conversations and in decision making. So I just wanted to share this final picture. All pictures are my own from my own life and my area. I come from a forest reindeer herding community in the north over to the mountain area. And this is my sister and my little son. Yeah. Thank you.
Thank you. That was an incredible message to remember as we move forward with our efforts. Please give a big hand to all of our wonderful speakers. I now want to invite them all to the stage for a panel discussion, including our remote speakers. Are there any questions in the room, here and online? Oh, just a moment as they come to sit down. All right, go ahead. Oh, I think there's a microphone coming around for you so that they can hear you.
I just wanted to understand the issue of snow loss for feeding the deer.
Hello, can you hear me well? Or okay, good. Because no. I'm not really sure about the issue with snow loss, but the issue we have is, and I actually questioned your research colleagues about that. But the issues that we have is freezing rain that has started to come more often in winters, and then thawing, refreezing temperatures that creates ice layers throughout the snow. And it becomes incredibly hard, actually, and makes it impossible for animals to dig through the snowpack. So that is why we must use supplementary feed if we cannot find grazing grounds, alternative grazing grounds for that. Thank you. I could ask that question though, if that's okay.
Yeah, I would add that it might be different in northern Sweden. That's a local area, but across the Arctic, there is a shorter snow season, and there may be more snow, but the snow duration.
Do our remote speakers have anything to add on that? No?
John Walsh, maybe I could comment that in Alaska, the transition from snow to freezing rain that Jason mentioned and that Susanna alluded to is a reality. The data show that there are increasing freezing rain events, and these events impact not only the rural communities and the husbandry, but they impact the urban areas as well. When a freezing rain event occurs in the early winter, the ice remains on the infrastructure and the roads for several months. That can really shape the character of a season in a high latitude urban area. So I think this freezing rain is one of the more under recognized impacts of a changing climate.
I can add there are rain on snow events in Svalbard as well. So this is a Arctic-wide issue.
Thank you. Does anyone else here have any questions? No?
Susanna, you mentioned the copper mine near your herding areas. I think so. Basically, I think what you were talking about was mineral exploitation for batteries and solar panels, among other things. What kind of development projects are going forward are threatening the areas where you live?
All of them. Yes, like I said, it's turning towards the Arctic for resources. So within my reindeer herding community, we have what I think is if I'm not mistaken, Europe's biggest land-based wind power industry park planned, and I'm not sure where in this. And we have obviously this mine, and that is now expanding. Will become another pit next to it, actually. Right? To go through the judicial way, but yeah. But in general, in Sápmi, we see these developments of for the green transition. Everything is covered in green and sustainable now. We need to increase forestry. We need to give up our lands for industrial landscapes in nature, and we need the minerals for batteries and yeah. So that is the reality that we're also facing, and I also underline the double burden. First, we have to live and adapt to the impacts of climate change, but then also adapt to new areas and new realities of changes in land use that we did not consent to. So yes, I hope I answered your question. Thank you.
Anybody else?
Hi, I'm Karle from Finland. I have a very broad and complex question, so I don't assume that you answer it thoroughly, but if you could maybe highlight one thing that maybe remains and one thing that is lost. So how does the 1.5 Arctic look like? Because we talk about the 1.5 here a lot. That should be our aim. Let's hope we make it. But what will we lose in the Arctic and what will be preserved in the Arctic? Thank you.
Yeah, Jason here. Even in the Paris climate scenario, which is important, the Arctic climate system becomes unrecognizable from the 20th century. So the Arctic communities prepare for a major disruption in precipitation, temperatures, permafrost, you name it, fire, and that's in an optimistic scenario. So adaptation it sounds, you know, that's even that doesn't sound very nice. What do you think?
And then both
I can add something here. You for the Arctic, you can multiply the global temperature by 2 or 3 times. So we're already talking about the Arctic reaching 2 or 3 degrees, which is completely different. The main point I have is the urgency of what's happening now and over the next decade, that climate models pretty much have a smooth increase, but in the northern Bering Sea and other places, we have internal feedbacks between temperature and sea ice and permafrost that are accelerating change and producing tipping points. So like northern Alaska, that the tipping point for the ecosystem happened a couple of years ago and is continuing. And so when we're thinking about extremes beyond what we've seen before, we should be thinking about rapid change events rather than a slow change. So the urgency of dealing with this and that the Arctic is a bellwether for the rest of the planet is a strong conclusion.
John Walsh, maybe I could add a couple of comments. Jason made the point that the Arctic will be unrecognizable, which is true under any scenario. We've already lost a large amount of sea ice, the snow cover has changed, and various other things have changed. But looking ahead under the various scenarios, only the scenario that meets the Paris 1.5 agreement, which is the SSP1, Only under that scenario does summer sea ice stabilize. It stabilizes at a much lower level than we've historically had. So the Arctic will be different from what it was. Only under that scenario does snow cover stabilize and precipitation stabilize. Again, they stabilize at different levels from previously, but only those scenarios stabilize. Under the other scenarios, we continue to lose sea ice. We lose all our summer sea ice. Snow cover continues to decrease through the 21st century, and precipitation continues to increase. So the scenario does make a difference. And tying in with Jim's comment, if we are to meet that 1.5 target, the SSP1 scenario, we need to act fast. I mean, there is urgency if that target is to be met. So I think these various comments do fit together, but the scenario choice is to some extent in our hands. If we act fast, we can make a difference.
Any other questions?
Hi, thanks everybody for your talks. I have a question for Jason mostly. You mentioned that there's sort of a damped acceleration in warming over specifically Greenland as compared to the rest of the Arctic. What mechanisms sort of are responsible for that? Is that the enhanced albedo of Greenland, or is it this other things at play?
So in a warmer climate, there's more moisture in the air, and we find evidence of a brightening of the upper elevations of Greenland. So yeah, it's more frost deposition, and so there is this damping feedback, and I think it's part of why Greenland is still an ice sheet, and the ice sheet over North America is gone. Also has to do with the planetary wave oscillation. Greenland anchors the wave sometimes, and it helps reinforce the ice sheet.
Thank you.
I would add it's probably not that Greenland is slower, but the Bering Sea and the Bering Sea sea ice loss positive feedback is why the temperatures are accelerating in those regions. So it's more due to the increase due to the lack of sea ice produces the 6-degree warmings.
Great. Do we have any other questions? No. You've got one.
I've been waiting to sit with the researchers who can answer my questions, actually. So we are experiencing freezing rain events and also extreme snowfall events. And I've tried to look at the research and see how come, because you have told us about increased precipitation and all those things, but how come we can have both freezing rain events in winter, but also these extreme snowfall events? And is there a clear trend on those?
There is more moisture in the atmosphere, and that can produce more snowfall when the conditions are right for that. So we see that even in the Alps, there can be really extreme amounts of snow deposited. At the same time, the planetary wave appears to be more wavy, and that can deliver a lot of heat north, and so you can also have a lot of rain or warm conditions. So the variability, and this is the word, the message that we hear from indigenous people that are in the Arctic year-round. They themselves recognize that the weather is more changeable, is changing more, and I think that's a consequence of the planetary wave, the so-called jet stream, becoming more variable and that's a consequence of the Arctic warming faster than the rest of the world.
Right. So the point there is there's big differences from year to year. So it's the increase in the frequency of these extreme events, not just a straight linear increase. So when thinking about it, you need to think about the extreme events that are variable between year to year and from region to region, rather than just a slow increase overall.
This is John Walsh. Just one other comment is that if you look at the climate model output, the Arctic is the region with the greatest expected increase of precipitation in a percentage sense. It's a much greater percent increase that's predicted for the Arctic than for the middle and lower latitudes. That's actually one of the, I think, unrecognized aspects of Arctic climate change in the climate model scenarios. So I think we're starting to see that show up in places like northern Scandinavia, that Susanna was referring to, in other areas. And some more snow, some of it will be rain, the freezing rain. But increase is a pretty clear signal in the climate research world.
Thank you. Yeah. Does anyone else have questions? Rachel.
Thank you. Thank you all for your presentations and the questions, mainly for Susanna, maybe for others as well. And yeah, thank you for your presentation, especially for sharing your really beautiful photographs. And I was just thinking about your question to ask, do you feel like there is enough like dialogue between Western scientists or researchers and indigenous peoples, and I guess both from the point of view of like thinking about research priorities when we're doing research in the Arctic, but also just in terms of a sort of two-way sharing of different types of knowledge? And what do you think a kind of improvement there might look like? Like, just any thoughts on that? Thank you.
Thank you for the question. I absolutely think there is room for improvement with involving indigenous peoples in research, and also importantly to include indigenous peoples at an early stage, not when you have the final project idea, or indigenous peoples have to be part of the research from the beginning in developing what is needed, and so I would say that there is room for improvement, and we see that also in several forests, which is a great opportunity, and our colleagues from the Inuit Circumpolar Council have produced an amazing report on I don't know the full title, but on ethical and equitable engagement of Inuit in research, protocols for engaging with Inuit communities in research, which is a really good material, and more indigenous peoples are developing such reports, which I think is super crucial also for ourselves, but also for the researchers reaching out to us and wanting for us to participate in their research. And so yes, I hope I answered the question.
Anyone else? Yeah.
John Walsh, and maybe I'll just make one comment. I think the co-production clearly does have room for improvement. There's a much higher, greater potential than we've realized so far. But I think that potential applies not only to the research, but to some solutions. Adaptation actions, for example, can be co-produced. And I think the activities like COP are very high level. There are a lot of policy goals that are set. I think if COP could direct more attention towards co-production of solutions at the regional and local scales, that would be advancing the engagement, the indigenous community, the science with practical solutions that matter to communities. So I see some opportunities there that go beyond what has come out of these previous COP meetings.
I would say there is certainly an increased recognition of working together, and I think it's really positive that there are younger indigenous scientists that are taking a main interest in all of this in different countries.
Next question, please.
It's more a comment concerning indigenous peoples in Finland have recently adopted a new climate act. It came in force in July, and part of that climate act is also to establish indigenous climate community. And the idea is to give the indigenous community both tools and means to combat climate change. And I think hopefully the Sweden and Finland would follow that. That's the usual behavior in the north.
Do any of the panelists want to piggyback off that comment? No? Good. Do we have any other questions? I actually have a question. So say you have a big project, $100 million, lots of money to work with. What's the first aspect that you would work on with said project? What's the main thing you'd want to tackle?
Ooh, okay, tricky question. So obviously that cannot solve the climate crisis, that amount. But I would definitely focus on strengthening indigenous peoples' organizations and representative institutions for our capacity in all sorts of ways to participate in research, to conduct research, but also to in all sorts of ways. So that will be my spontaneous answer.
Walsh, my response would be that I'd bring policymakers from the big countries to the Arctic and pay for them to come up and experience see what the Arctic is undergoing in terms of change, just to show them that the changes are happening in the here and now. There's a need to act, as Jim puts it, urgently. But I do think that experiencing or seeing the change firsthand is at least one step in getting some action from the more influential sides of the policy world.
Yeah, I would say we need to work both in the large scale that John is talking about, that gives us some hope for slowing things down. But in the northern Bering communities, they've already are losing their economic basis. The fish processing at Nome has closed for lack of product, and in all of this with changes we've never seen before, we really don't know where they're going. So for Northern Alaska, you really need to be monitoring what's happening every year to consider how these changes are going to be come out with tipping points and so on, and not really relying just on the smooth curve from climate models.
and about the smooth curve, that's where our attention is focused in the reports. It's the creeping upward of these trends, and what fortunately is starting to change. It's because extremes are grabbing our attention in ways we cannot ignore. So I would base a research project studying the variances instead of the average. And there we learn a lot about what's happening now, and we don't have to wait until mid-century, end of century, because these extremes that are happening now, they can teach us a lot about what's really happening.
Thank you. And unless we have any other questions, I think we're going to wrap up the event. So just in conclusion, I'd like to say that the Arctic is changing faster than we expected. The indigenous and local communities are already deeply affected by these changes. And it's clear that what happens in the Arctic does not stay there. As John Walsh said, the future of the Arctic depends upon the scenario we decide to follow. It's up to all of us in the room today to make sure that we limit these terrifying effects of climate change in the Arctic for its inhabitants, its ecosystems, and the entire world. Thank you. And also thank you for our panelists today and all of our participants for joining the event.